Welcome! In the previous video we compiled some statements into C code, and in this one we're going to parse some function definitions. This is what I expect to be able to parse by the end of this video. We will not be parsing any arguments or returned value, just the statements inside the body of the function. And this means that we'll need to add a few tokens, in this case the double colon, the left brace and the right brace. So in the tokenizer.h file we can add their kinds, and we can very easily tokenize them in the tokenizer shop function by adding the following code, noting that since we are using string views, we can have symbols with more than one character. After that, in the parser.h file, we should be able to create a parse function definition function. And as you know, a function definition is going to begin by an ID. If you go to the demo file, you can see that this is the ID. The ID must be followed by a double colon. And then we must have a left and right parenthesis. For now, we'll not be parsing any kind of arguments, so we can report an error in case they exist. And finally, the body of a function begins with a left brace. If that's not the case, we can report an error. And once again, we can report an error if we didn't find the double colon symbol. Now we can shift all of the tokens, in this case the ID, the double colon, the left parenthesis, the right parenthesis, and the left brace. And after that, we can parse all of the statements inside the body of the function. After parsing all of the statements, we must check if the current token is a right brace, otherwise we report an error. If the current token is a right brace, we can shift it. Finally, we can just return a new AST of type AST function definition, but first we need to define this new kind of AST. So inside our AST kind, we can add AST function definition and remove AST statements. Then we can create a new struct called AST value function definition that is going to store the function name and the statements of the function body. After that, we can also replace the statement's value by the function definition value. And finally, we can create a new constructor for the function definition. Unsurprisingly, the implementation of such constructor is the one that you are expecting. Now we can temporarily change our parse AST from tokens to actually return an ASTs array. And now we can do what you are used to see, create a result, loop while the tokens count is greater than 0, parse a function definition. If the function definition is end of file, we can return the result, otherwise we append it to the array and then return the results. Inside our main.c file, we can temporarily comment this code. We can also bring back demp AST. And then we can replace the case of AST statements by the case of AST function definition. In this case, we are printing function definition followed by the name of the function and then all of the statements inside that function. After that, we can also temporarily comment out this loop inside writer.h. Going to our run.sh script, we can comment out the last two lines temporarily. And now we need to fix some errors. Note that this pointer is no longer needed. And this code needs to actually be replaced by this one. So instead of AST, we are actually going to have ASTs. And then we are going to loop through all of the ASTs and dump them. Now if we run our run script, you'll be able to see that we were able to parse the function hello and the function main. The function hello contains two function calls and the function main contains a single function call. And this is how you parse a very bare bones function definition. In the next video, we are going to compile them.